then I start. So my talk is indeed about macro, micro, and nanoplastic. And I would like, first of all, to try to just describe this issue without too much emotions, with a scientific approach, mainly. And I will start with the evolution of polymers in the last 100 years, probably the beginning of polymer science and also of polymer industry is 1920, when Staudinger has published a paper about polymerization, and in this paper he made a hypothesis that most of the strange substances which were known at that time, such as rubber, starch, etc., proteins, they are long chain molecules. And from that time, the science and industry of polymers started. Well, it was a rapid start, and most of the polymer industry started to develop after the Second World War. Although before the World War, it was many advances, like nylon, which was synthesized by Carothers in 1935 in DuPont. But after the Second World War, really the production of various plastic materials was accelerated considerably. And this means that at the moment, about 80 years, polymer industry is producing a large amount of polymers. In the beginning of 50s, well, the diversity of these polymers was increased considerably because of the discovery of the Ziegler-Natta catalysis. And also, by the way, at that time, Watson and Crick has described the structure of the double helix DNA, and it was understood that the main processes of the life are also connected with the polymers. So indeed, polymer start to develop at a very rapid speed. And at the moment, I would say that, sorry, I think that I have to restart. And I think that actually, at the moment, most of the objects which are surrounding us are connected with polymers. These are, in this picture, you can see plastics, rubbers, fibers. Most of the clothes are now connected with are now composed of fibers, and synthetic fibers. Normally, it's a very important part of any part of clothes. Polymers are can produce a lot of films. So actually, polymers around us is really important thing, and we ourselves, we are consisting of polymers because both DNA, RNA, proteins, polysaccharides, the main things from which our organisms are composed, they are also polymers. So our everyday life is connected with polymers. Both household items and construction items, packaging, plastic containers, they are in our life, and clothes, etc., etc. And this really delivers us a problem, which is normally described as the problem of plastic waste. Although I would like to mention, and in this slide it is outlined, that plastic waste is only from 8 to 15% of municipal solid waste, depending on the country. But still, this is a large amount, and normally the pictures which are like in this slide, they are demonstrated, and it is normally argued that plastic garbage may be the cause of blockage of drainage systems, emission of toxic gas. If it goes to aquatic biota, it makes damage of aquatic biota, etc., etc. Normally, we are also frightened with the pictures like here, pictures of the garbage islands in the world oceans. Well, because of the currents in the ocean, the garbage, light garbage is normally just accumulated in certain places in the ocean. These places are shown on this map, and the largest is the Great Pacific Garbage Island, which has the size of 1.6 million square kilometers. And the concentration of plastics is about 100 kilograms. It is considered to be 100 kilograms per square kilometers. It is a misprint here. But well, in principle, I would say that if you go really to the garbage island in the Pacific Ocean or in Indian Ocean or in any Atlantic Ocean, you never see the things like this. You always, you see the man is on a small boat, and it is clear that if it is on the small boat, it's not in the middle of the ocean. Actually, if you go to the middle of the Great Pacific Garbage Island, you do not see anything, spectacular. You do not see such a set of garbage. These are small particles which are not seen actually by the eye. But still, these particles can cause mechanical damage to the animals, and such pictures like shown on this slide, they are quite well known in the literature, which deals with the damage to the environment for the plastic in the ocean. In principle, if you look at the numbers, these are the numbers a little bit old, 2017. The plastic which was produced by that time was about 10.1 billion tons, no longer used 7 billion tons, recycled no more than 9%, burned 12%, and this means that 5.5 billion tons of plastic waste pollute ocean and land. Actually, of course, when this became apparent, this situation became apparent, people start to think what to do with the plastic, because the main idea is, main thing is that the plastic, normally this is the most common polymers are polyethylene, polypropylene, polystyrene. So they all connect in the main chain, the CC bond, which is not so easy to destruct. Well, it is normally destructed in the course of the exposure, for example, to ultraviolet irradiation, to some other reagents in the surrounding media, but still, if you do not do anything, then the materials from polyethylene, from polypropylene, they degrade for 10 or even hundreds of years. There are three main approaches to deal with this problem. One is recycling. Another is burning, is combustion, because, well, polymers is rather reasonable fuel to generate energy. And I would like to say, the main part of polymer is just are exposed to waste burial in dumps. And in dumps, there is a biological degradation of polymers under the influence of natural causes. I would like to stress, first of all, normally people are always thinking about solution of this problem in terms of recycling. But sorting of waste for its subsequent use can only postpone the contamination of environment. Even in best case, only several times, polymers can be recycled only several times. And in the end, well, the properties of the recycled polymers, they degrade with each cycle. And after all, polymer material will finish its life either in the garbage dump or it will be burned. Therefore, just to solve the problem, the key problems are either clever design of garbage dumps, smart dumps, or efficient catalysts, which are preventing air contamination in the process of burning, so smart catalysts. In principle, both problems are solved at the moment. For example, I would say that burning is the way which is used by most of the European countries, which do not have a lot of space, free space. And in principle, this is a reasonable process, which with the help, with certain subsidies from the governments, it can be quite efficient. Here on the slide, you see the rather famous Spitteltau plant in Vienna. This is more or less in the center of the capital of Austria. And in principle, nobody is afraid of any toxic gases which are coming from this plant. And even, well, the housing near this plant is profitable because the energy which comes from burning of polymer materials, it is cheaper than in the other places. In principle, if the modern plant has the capacity of 1,000 tons per day, it can actually eliminate the waste problem for a city with a population from 500,000 to 1 million people. So this is a reasonable thing, but of course, the catalysts which are used, they are rather expensive. And therefore, although this is one of the possible ways to eliminate polymer waste, first of all, it requires careful careful selection of the polymers which has to be burned. And second, the problem is that still the energy from this source, because of the price of catalysts, is higher than just by burning oil or gas. Well, just disposal in the dumps, this is a much cheaper thing. And such countries as United States, China, Russia, which has a big territory, they normally come to this solution of the problems. And I would say that in principle, the construction of the dumps in a scientific way is a very interesting problem. One has to not only to bury this well, garbage in the normal way in order to avoid the well, emission of the toxic gases, but also one has to have well, the possibility to well, have to use the territory of this dump after it is full with the garbage to use for the growing of the gardens, just to have well, restored territory after the garbage is used. Well, but this, in principle, this problem is solved. Well, here you can see some of the pictures, both just the Fresh Kills Park on Staten Island in New York, Ariel Sharon Park in Tel Aviv. These are the places which were the places for the big garbage landfills, and still now these are green woods, and how to say, no problems with living or making some, well, some recreations in these places. So in principle, just I would say that the attention to the fact that our nature is contaminated with the garbage is a little bit exaggerated, especially taking into account that the plastic garbage is only a small fraction of the general garbage, including the garbage from the building industry, the garbage which contains food, etc., etc. But most important is that if we look at the contamination of the nature by the synthetic polymers, one has to compare this with natural polymers. And that this comparison always comes to the conclusion that actually natural polymers are is the main source of polymer pollution. Normally, people are saying, well, natural polymers such as cellulose, they are degrading. In principle, they are degrading. But if you look, for example, at the large piles in Venice on which the houses in Venice are built, they were built about 1,000 years ago or even more. And still they are staying and they are not degrading. The same thing is just with chitinous cells of crustaceans, etc. And especially it is possible to compare the production of natural polymers and of synthetic polymers. The annual world production of synthetic polymers is 400 million tons. But the annual production of natural polymers, which is produced by nature, well, mainly is cellulose, is 10 or even more than 10 billion tons. And it's much more, and cellulose is not degrading so easily as some people are saying. And especially you have to compare these 400 million tons of polymers with the same number, 400 million of tons, is the annual production of paper and cartoon. And it is known that paper and cartoon is one of the most ecologically damaging industry, production of paper and cartoon. And also it requires a lot of wood, and elimination of wood is not a good thing. Actually, there is a statistics that, well, this change of the packages in the supermarkets, which occurs in Europe about 10 years ago. In Europe, it was mainly plastic bags. Now it's mainly, bags from paper. And actually, something is, if you do not see me, do not hear me, then please tell me that, because there is some sign here. So actually, just as soon as this change was implemented in Europe, the number of the square of woods in European countries start to decrease considerably. So it's not at all clear for me that change of plastic bags for paper bags is a good thing. By the way, plastic bags were just invented in 1959 by one Swedish engineer just as a substitute for paper bags, because he argued that plastic bag can be used many times and paper bag can be used 1 or 2 times and then it is becoming useless. So in principle, just this slide tells you that it's not so clear that well, the problem of pollution with natural polymers is so important, especially since Mother Nature takes care of the pollution of natural polymers for billions of years. And the slogans that we have to cut the production of polymers are meaningless, because it's clear that our civilization will not be able to function without increasing of the production of polymer materials. Especially you can look at the Asian countries where the population is very high, and it's clear that without plastic envelopes, etc., for food, for example, it will be a lot of infections which will cause much more danger. Do you see the change of the slide? It's okay. Now let's turn to the problem of microplastics. Actually, what is microplastics? According to the well, definition accepted in the scientific literature, microplastics are particles of polymeric waste less than 5 millimeters in size. And normally when I tell about these 5 millimeters in the scientific audience, physical-chemical scientific audience, they are saying probably it is a misprint here. It's 5 microns, but not 5 millimeters. But this is indeed 5 millimeters. This is a general definition of ecologists. And of course, for scientists, it's just macroscopic size. But this is a definition. What can I tell you about the microplastic? Any plastic, first of all, any plastic waste, due to the natural degradation, eventually produces microplastic. It's clear that, but this is true not only for plastic, but for any other material. Normally, in the papers produced by ecologists, they are counting the number of plastic particles, but this is makes no sense, because it's clear that if you have 5 millimeter fragment of plastic, you can obtain from it up to 1,000 fragments of 0.5 millimeters. So it makes no sense to measure the concentration of microplastic in the number of particles per unit volume. It should be not number, but well, the distribution of sizes, etc. Then let's go to the point 4 here. It's important about this distribution of sizes. Depending on the size, microplastic particles have different effects on living organisms. In the range from 5 microns to 5 millimeters, this is mainly a mechanical effect. Because these are mainly macroscopic particles. At a particle size from 50 nanometers to 5 millimeters, to 5 microns, sorry, 50 nanometers to 5 microns, particles can in principle penetrate from the stomach to the blood, to the other organelles, and at smaller size then can penetrate cell membranes. So if we are speaking about the possible damage of microplastic to the living organisms, including human bodies, of course, we have to confine only to particles less than 5 microns. or even just 1 order of magnitude less than 5 microns. But in this range, any particles, any nanoparticles can have toxic effect. There is nothing special about microplastics. And also important thing, now we come to the point 3 from this slide. Some people normally do not understand what is the main source of microplastics in this range from less than 5 microns. According to the International Union of Conservation of Nature, 2 main sources of microplastics in this size interval is, first of all, fibers of synthetic fabrics that enter environment when washing clothes. 35% of all the microplastic in the range of less than 5 microns is from washing clothes. And 28% are elastomer particles that are generated due to the friction in contact of car tires with road. So if you add 35% with 28%, you come to the conclusion then that most of microplastics, more than 2/3 of all microplastic, is because of clothes and because of car tires. And therefore, it makes no sense to fight microplastic by banning disposable plastic bags or dishes. And normally, just people are starting with banning plastic bags, which make completely no sense. And if somebody is really afraid of microplastics, then there is an easy way to eliminate microplastic. You just boil water, and if you boil water, everybody knows that in water there is a lot of calcium salts. They make the solid envelope of microplastics when boiling, and it goes down to the walls of the boiling reservoir. Well, this is the reference to the paper when it was discovered, that this stuff was discovered. So general conclusion is that, the main, the main direction of fight against microplastics is not always correct. And most important thing is that the harm of microplastics is probably overestimated, because plastic is never in the distilled water. It is in natural aquatic environment, and therefore the surface of any microplastic particles should be coated with numerous surface active compounds, like remnants of some biota in the water, or some other surface active compounds. And this will be just like the surface of inorganic particles, like sand. So the core is not important. What is important is the reaction of the organism, immune reaction, immune response of the organism is not on the core, whether the core is made by sand or the core is made by plastic, but on this biota which is around corona of this particle immersed in the biological water. So the immune response to microplastics should be the same as to sand particles, with which many organisms have coexisted with hundreds of millions of years. Therefore, the harm of microplastic to health is actually not proven by science. Well, in principle, I can imagine that it can be the harmful effect of microplastic particles, which are somewhere in the river, and they are going through some water near some plant where some toxic compounds are emitted, and these compounds are adsorbed on the surface of the particle. And then if the fish, for example, is eating this particle, then these contaminating substances, harmful substances, are in the cooperative way released in the stomach of the fish or something like this. But this should be some interdisciplinary program which involves specialists in the field, both in the field of physics and chemistry, life sciences and geosciences. And it is not correct to tell in such a straight manner that, well, microplastic can be harmful. I will give you one or several examples. Well, in the beginning of 2024, it was a big noise in the scientific and near-scientific literature because of this paper in the Proceedings of the National Academy of Sciences. It was about single particle chemical imaging of nanoplastic by SRS microscopy. What was done in this paper? Actually, this is analytical paper. It analyzes water from the plastic bottles, but the main contents is that this paper proposes a new analytical approach to determine the concentration of submicron-sized particles dissolved in water. And it is based on coherent anti-Stokes Raman spectroscopy. What is new? This method allows to determine not only the concentration of particles of given size, but also their shape as well as the origin, what polymer the particles are consisting of. And it goes from the micron range down to the nanometer range. And of course, when you go from the higher sizes to smaller sizes, it's clear that the number of particles which was described discovered was immense, 2.4 multiplied by 10 to the 5 particles per liter of water. This is, of course, a very big amount, but on the other hand, this is in the nano range. So the less are the particles, the more is the number of particles per unit volume. And it was discovered that most of these nano-sized particles are not polyethylene terephthalate particles from which the bottles are made, are polyamide nanoparticles. Here are the corresponding graphs, and you see that polyamide nanoparticles, it's in blue range, it's more than 1,000 particles per in the range of when the particle is particles are counted, and polyethylene terephthalate is much smaller, it's less than 10 particles. So it's 2 orders of magnitude. But this is completely understandable because it's known that the less are the particles, the more is the contribution of polyamides from washing clothes. So this means that actually you have to you have to read the scientific papers about the harm of microplastic carefully and try to understand what really is done in these papers. But as soon as this was published, it was headlines in the news media that, well, nanoparticles, the microplastics will kill us. And it is, if we do not take into account any measures, then, well, it will be the main enemy of the humanity. Actually, in last year, it was 20 years since the discovery of the term microplastic, and Richard Thompson, which was the scientist who described this this term, has written the paper, review paper in which he and his co-authors reviewed the development of the microplastic science. And it was a rather reasonable review. I would like to cite only two sentences. One is that in the case of microplastics, scientific data is filtered through social perceptions, and decision makers and policy in politics and industry consider the impact of public opinion, votes, reputation, and image. And the second fragment is that bans on unnecessary and avoidable plastic products, as well as improvements to product design, could be promising. However, there is a risk of unintended consequences if interventions are implemented without proper impact assessment and careful consideration of the socio-technical and geographical context. That's what I mentioned. For example, in the Asian countries, well, in China, Vietnam, etc., it's completely impossible to avoid the use of plastic packages, etc., because this this would lead to the very serious problems for the health, and this will be the real problems, not the problems in the far future, like people are speaking about microplastics. But so this paper, it was rather reasonable, but what journalists are, what kind of conclusions journalists were have drawn from these papers. Scientists have called for a global fight against microplastic. Scientists are calling to attention to the microplastic. Global action is needed. Harm of microplastics to the environment has been proven, etc. There was nothing of these headlines in this rather reasonable scientific paper in Science. One more thing which caused a lot of noise this year. It was, I think, in the beginning of February or in March. The paper in Nature Medicine, bioaccumulation of microplastics in the descendant human brains. The article, in this article, the authors have tried to investigate the microplastic in the different organs of the died people who just have said that, well, their remnants can be investigated by scientists. And it was discovered that mainly by microplastics is accumulated in the brain. Moreover, that if the brain is in the brain of the people who are having dementia, it is much more microplastics than in the normal human brains. And another conclusion was that the amount of microplastics in the human brains is enough to make from these microplastics a tablespoon. That was really big noise. I tried to analyze this paper in detail, and first of all, in the paper, it's not written that there is a causal link between microplastics and dementia, because actually all kinds of brain diseases, they are connected with the failure of the barrier between blood and brain, and well, it is the cause and the consequences are just changed in their sequence. But mostly just about the spoon in your head, it was just a mistake of interpretation of the results. What was the results? What was the tissue analysis method? First, tissues were extracted from formalin when they were stored and placed for several days in a solution of strong alkali, potassium hydroxide. which in theory was supposed to digest biological structures. And then it was washing and centrifugation and finally examination of what remained. But the authors have completely not explained the fact that in the kidney and liver tissues, they were digested almost completely. The material remained was only 0.6% of the initial material, while in the brain it was 8.2% tissue was remained, so an order of magnitude more. Therefore, and from this it's clear what happened. Actually, after the solid solid remnant material was obtained, they made pyrolysis and made mass spectrometric analysis of pyrolysis products. But it is clear that, and they are saying, okay, in the brain there is a polyethylene, but when you are analyzing the results of pyrolysis products, then you cannot distinguish between normal lipids and polyethylene, because you just analyze only small sequence of CH2 groups. Only in the gaseous phase, these are the only products. And therefore, and it is known that in the brain, there is around 60% of lipids, while liver tissue, for example, contain only 5%. Therefore, most likely, the polyethylene, which was discovered in the brain, these were simply the lipid structures which survived not only strong alkali, but also subsequent washing and centrifugation. And after this result was clear, people discovered that this was indeed the fact. So there is no brain, there is no spoon in our head, and there is no particular accumulation of any microplastic in our brains. Well, I can tell a lot of things, I have a collection of different nonsenses which were just described in the literature just during this year. One, for example, I don't know when I have to stop, but let's say another, I would describe you another interesting story. Just paper from one of the governmental agencies in the United States. They discovered that you do not have to give birth to your child near the sea, only in the core of the continent. Why? Because they have tried to make some correlations in the statistics between the weight of the newly born child and the distance between the place where the place of birth have taken place and the seashore. And they described that the closeness to the seashore is not good for the weight of the newly born child. There is a lot of methodological nonsense in this paper. It is more or less clear, but most stupid thing is that they connect this statistical correlation to the microplastic in the ocean. On the other hand, it is known that the largest contribution to the atmospheric air pollution are fresh emission from the cars, of the carbon particles. Fresh emission are accounting for approximately 46% of particles. There is also older emissions, industrial emissions, etc., etc. And the fraction of microparticles in all the dust which is available in the cities is 0.67%. So, well, it is uncomparable with the normal city dust and normal just, well, particles which are, in spite of all the things, they are coming from the cars when they have, when they are working. So, well, it looks likely that the scientists, they are using this, well, type of just headlines to just to sell their the investigations and to frighten the people. Another, I will be now just probably more concise. Another thing, quite recently, people are saying that carrots, root vegetables, apple, rice, seafood, normally it's considered to be good for health. But scientists are saying, well, and here are the headlines, that no, they are not good because they contain even this type of things, this type of products, they contain a lot of microplastics, and microplastic will kill you. So these horror stories can be objectively harmful because they can lead to unhealthy diet, high in meat, flour, or sweets. And actually, this can cause you serious illnesses, and the long-term consequences of microplastics may never occur. Just this is the thing that in this slide it is described that actually when we are speaking about biodegradable alternatives, normally they are much more harmful because what does it mean biodegradable bag? Plastic bag. Normally this is plastic bag for which starch is added to polyethylene or polypropylene. Starch is also polymer, but natural and cheap. So in principle, this addition is economically feasible, but in this paper, it is shown that actually if you if you add to the food of mice a lot of such biodegradable plastics, it's much more harmful to mice because it produces small particles to a much higher rate than normal plastics, which even if mice eat it, it is going through the organism of the mice in the easy way, in the normal way. Probably I will skip this slide and I will come to the conclusion that the harm of microplastics, the general conclusion is that the harm of microplastics is probably overestimated. Actually, the problem exists. It should be solved by scientists who use objective physical-chemical methods, and the efforts of the scientists should be aimed at separating the real danger from the imaginary one, as well as explaining the results to the whole society. And let's compare the figures again. In the world, we produce 400 million tons of polymers. We produce the same number, 400 million tons of paper and cartoon, and this is ecologically very harmful industry, and which requires this wood materials. In the world, we are producing 2.5 billion tons of wood annually. Normally, wood is considered to be ecologically good, but actually, if you eliminate woods, then you come to the problem with the global ecosystems. In the world, annually 10 billion tons of natural polymers is produced by the nature. And what is most striking, annually in the world we produce 30 billion tons of concrete, which actually easily crumbles, easily gives microparticles, and yet no one talks about microconcrete. Actually, microconcrete is a very fashionable material which is offered by the building industry. And this is the last slide, the conclusion. Every material is degraded by the environment to small particles. Every nanoparticle can get into the human body and blood, not just microplastic. For example, the walls of the houses built by humans eventually crumble into the dust and sand, which can also enter living systems. There is no evidence that microplastic particles are especially harmful. For millions of years, humans have coexisted with ordinary dust. Every particle in the human body exists in the environment of biological fluids, in which various residues are present, fragments of bacteria, proteins, etc. And as a result, particles become surrounded with a biocorona, the shell of these residues, and can no longer affect the body on their own. This is the case with all particles, regardless of their composition. Microplastic is no exception. There is no difference for the body, microplastic or dust. Okay, so with this, I think I finished. Thank you for the attention.